This video is primarily going to cover domain and range of the 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. First thing I want to talk about are periods of the sine and cosine. Let's talk about the period of the sine and cosine, and this will lead us to the domain. We're not going to worry about tangent and cotangent just yet. Okay. The thing to keep in mind is there are an infinite number of angles on the unit circle. Yeah, you have some circle, the unit circle. Woohoo! And we're just so used to multiple of 30, a multiple of 45, or a multiple of 90, and you know, this is 225, etc. I can find exact values, 3 pi over 2, 1/2, negative root 2 over 2. I can find exact values when the reference angle, recall that the reference angle is right there, that's your reference angle would be there. If it's a multiple of 30, 60, or 45, great, I can find it. But that doesn't mean you can't find the sine, cosine, blah, blah, blah of 83.6 degrees. You can still find the measure of that, the sine and cosine of that angle. It's called your calculator. You can still find, what is this? Let's say it's negative 243.1 degrees. It's on the unit circle, but I can't find its exact value. So how many angles are on the unit circle? An infinite number of angles are on the unit circle. So if I asked you to find, let's just go back to exact values. If I asked you to find the sine of 30 degrees, 1/2, that's great. If I asked you to find the sine of 390 degrees, it's also 1/2. Oops, I forgot my degree symbol. If I asked you to find the sine of negative 330 degrees, it's still 1/2 because you're starting at 30 and you're going around 360 and around 360. Or maybe you're starting at 30 and you're subtracting 360 and subtracting 360. So this is called periodic. This is called periodic. And by the way, we should really do radians. Sine of pi over 6. The sine of 13 pi over 6. This is the sine of negative 11 pi over 6. Okay. Okay, so we're going to say that these angles are periodic, or the sine is periodic. If you take some angle, you have the sine of some angle theta, 30 degrees, and then we said, oh, add 360, that's the same. Subtract 360, that's the same. The sine of theta is the same as the sine of theta plus or minus 2 pi. Pi over 6 plus 2 pi, 13 pi over 6. Pi over 6 minus 2 pi, negative 11 pi over 6. So these are periodic. This is going to lead to the domain. This is going to lead to the domain. I'm just going to leave a little bit of space here. So the domain of the sine function is all real numbers. Theta can be anything I want. Unless there's a fraction or a root or a log, all real numbers. There's a fraction, you got to be careful because you can't have 0 in the denominator. If it's a log, you have to be careful because the argument must be greater than 0. If it's a root, you have to be careful because you can only root positive numbers in the real number system. The same thing is true for cosine. Cosine is also periodic. Oops, I wrote, this should say cosine. So the domain of cosine is also all real numbers. As I said not too long ago, we're going to look at secant and cosecant, and you have to be careful because if there are zeros in the denominator, that's going to cause major problems. Let's look at cosecant. Cosecant is 1 over the sine. This is a problem. This is a problem. If the sine is 0, then the cosecant is undefined. If the sine is 0, then the cosecant is undefined. Okay. And for secant, that's 1 over the cosine. So if the cosine is 0, then the secant is undefined. There's no way that the domain can be all real numbers. There are places on the unit circle where the sign is 0. So therefore, the domain can't be all real numbers. I have to figure out where is the sign 0. Okay, well, I'm going to draw my handy dandy little unit circle. Okay, so I think they may have mentioned that these are like super, super important points on the graph. If the sine is 0.3, fine, I can find the cosecant. If the cosine is whatever, 0.96, I'm okay. Problems. Okay, so we have cosine, sine. So let's talk about the cosecant first. All right, so sine of theta is 0. Sine is y. So the sine is 0 at 0. Pi. Oh, but it's cyclical. 2 pi, 3 pi, 4 pi. All that pi. Thanksgiving's coming up. It's a perfect opportunity to talk about all this pi. Well, I can't just write 0 pi, 2 pi, 3 pi, 4 pi, right? There has to be a much better way to write it. So the cosecant, sorry, let's change that. Let's write the domain first. Got white out now, feels so much better. The domain, I just wrote it wrong again. Domain of the cosecant function is all real numbers. What? No. It can't be all real numbers. Well, of course it's not all real numbers. We're going to put a restriction on it. All real numbers, theta not equal to integer positive and negative whole numbers, integer multiples of, lots of white out today, pi. The domain of the cosecant function is all real numbers, theta not equal to integer multiples of pi. Zero, 1 pi, 2 pi, 3 pi, 4 pi, or you could go backwards, 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, blah, 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 blah. So that is the cosecant. You have to figure out where is the sign 0. Everywhere else is okay, but if the sign is 0, no can do. Okay, let's look at the secant, which is very similar. So the secant. Is where the cosine of theta is 0. Where is the cosine of theta 0? Well, the cosine is x. X is 0 at, so the cosine is 0 when theta is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, blah, blah, blah. So as long as we're not plugging in pi over 2, secant's good to go. As long as theta is not 3 pi over 2, the secant is good to go. The domain of secant theta is equal to all real numbers. Theta not equal to, this is weird, odd integer multiples of pi over 2. What? Huh? Why odd integer multiples? Okay, great. Because if it's an even integer multiple, 1 pi over 2 is great, but 2 pi over 2 is pi. 3 pi over 2, fantastic. 4 pi over 2 doesn't work, that's 2 pi. 5 pi over 2, okay. 6 pi over 2, no, 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 no. So it has to be odd integer multiples of pi over 2. You can find page, I don't know, like 383, 385, something like that. Okay, so that's the domain of secant and cosecant. You have to be careful because there are fractions involved. So I've left out tangent and cotangent. Well, guess what? You've kind of already done tangent and cotangent. You've kind of already done tangent and cotangent. I have a feeling I'll be flipping the notebook back and forth here. So let's look at the domain of tangent. Well, tangent is sine over cosine. Tangent is sine over cosine. So if cosine of theta equals 0, if cosine is 0, then tangent is undefined. If cosine is 0, tangent is undefined. But didn't we just talk about where the cosine is 0? So the denominator of cosine is the same as secant. If the cosine is 0, then the secant is also 0, which we just did. or sorry, undefined. I misspoke. If cosine is 0, both tangent and secant are undefined. So the domain of tangent is the same as the domain of secant. And that is odd integer multiples of pi over 2. Tangent domain is the same as secant domain because they both involve cosine in the denominators. So along those same lines, the domain of cotangent, and cotangent is cosine over sine. So the domain of cotangent is the same as the cosecant. Because cosecant is 1 over sine. So for cotangent, it is all real numbers. Oh, you know what? I'll go back. I forgot the all real numbers part. Is all real numbers theta not equal to integer multiples of pi. So let's go back. The domain of tangent, which is the same as secant, should say all real numbers except, that's a big thing I forgot to write in. All real numbers except odd integer multiples. So looking ahead to the final exam, I would definitely be writing down my domains and my ranges. I think that's going to help. Okay, let's take a look at range. Let's take a look at the range. All right, so again, I have my beautiful circle. Okay, so let's look at the range starting with sine. Let's look at the range of sine. And actually, the range for sine and cosine are the same. Let me use a darker color. So we've already decided that for cosine and sine, that theta can be anything we want, okay? Because the sine and the cosine are cyclical, they're periodic functions. So the range, so cosine and sine. The range for sine and cosine. So if you look at cosine, we have 1, and we go all the way up to the cosine is 0, and then to the cosine is -1, and down to 0. So you have positive values for cosine, and then they go up to 0. And then you have negative values for cosine, down to -1. And then the cosine increases to 0, and then increases to 1. So the range for the cosine is between -1 and 1. And the same is true for the sine. The same is true for the sine. All right, so to find the range of the secant and the cosecant, I think the easiest way to do that is to sketch a graph. We will talk more significantly about graphs? Sorry, I changed my mind. I'm just going to give you the ranges right now for secant, cosecant, tangent, and cotangent, and we'll talk more specifically and derive them when we get into graphing. So for right now, the ranges, if you would like to look, are on page 384. So we have that the range for cosecant, it's less than or equal to -1 or greater than, I forgot the theta, greater than or equal to +1. So for right now, you're just going to need to trust me about the range. And the same thing is true for the secant. The range of the secant is less than or equal to -1 or greater than or equal to +1. Your book does an algebraic explanation. It's kind of confusing with a lot of absolute value in it, but you are certainly free to look it up. Tangent is -infinity to infinity, and the same thing is true for cotangent. The same thing is true for cotangent. Okay, so that is range domain of all the 6 functions.